Hello friends, good morning, and this is the third lecture for the isomerism topic, and the question number 26. The question is ring chain isomers develops when? Okay, so ring chain isomers are the isomers in which one of the isomers has open chain structure while the other has ring structure. For example, let's consider these two. This is butene and this is cyclobutane. Both of them have same molecular formula, so they are the isomers, but one is in the ring and another is in the chain. So these two are ring chain isomers. So one is correct. Now if the ring size is different, if there are two isomers in which one has the ring size is different from the another, then it can also be a ring chain isomer. For example, this is the methyl cyclopropane and this is the cyclobutane. Again, both have the same molecular formula, so they can also be ring chain isomer. So the ring chain isomers are the isomers in which one is in open chain and another is in ring, and also if they are both having the ring structure, then their ring size should be different. So the first statement is one isomer has open chain structure while the other has ring structure. So this is correct. Now coming to the second one, both isomers have ring structure but their ring size should be different. Yes, this is also correct. This is the example of this one. Both isomers have ring structure but their ring size should be same. No. And option D is both A and B. So option D is the correct one. Both A and B will be the correct answer. Now coming to the question number 27. Now, this is the questions based on the ring chain isomers. Among these ring chain isomers are, so let's see here. If you want to find the molecular formula for this compound, okay, so this will be C4 and there will be 2 hydrogen here, 2 hydrogen here, so 2 to 4, 1 hydrogen here and 1 hydrogen here, H6, and again here C4, there will be 1 hydrogen on these 2 and 2 hydrogen there will be on these 2 hydrogens, so C4H6, and in this case also this is C4H6. So all of them have the same molecular formula. So all are related as isomers of each other. Now for the ring chain isomers, let's see here. Ring chain isomer 1 and 2 are having the same molecular formula, but one is in open chain and another is in ring, so they are ring chain isomers. Now coming to 1 and 3, again one is in open chain and another is in ring, so 1 and 3 also will be ring chain isomer. Coming to second and third, both are in ring structure but their ring size is different. Here the ring size is 4, but here that is 3. So again they are related as ring chain isomer. So in fact all of them are related as ring chain isomers. So the correct option will be D. Coming to the 28th number question. Now again among these ring chain isomers are, so first let's see, there are 1 2 3 4 5 6 7 carbon in all these. In this case also it is 7 carbon and in this also 7 carbon, and if you look carefully then all have the same du, okay, and the du is 1, so the number of hydrogen will automatically be same for all this. So the molecular formula for all the three is the same. Now 1 and 2, just 1 and 2 both are in ring structure, ring form, but their ring sizes is different. The ring size is 3 and here it is 5. So 1 and 2 will be the ring chain isomers. Again 1 and 3 similar to this one, the ring sizes is different and they have the same molecular formula, so again both will be ring chain isomer. 2 and 3, again they have the different number of carbon atom in their ring, so the ring size is different, so again they will be ring chain isomer. So in fact all of these are related as ring chain isomers. So this is the ring chain isomers. Now coming to the next, a functional isomers are those which differ in, okay. So as we know the definition of the functional isomers are that isomers which differ in functional groups, okay. So the first option is number of carbon atoms in their parent chain. No, this is incorrect. Number of carbon atoms in their ring, again this is incorrect. Position of an atom or group, no. Functional group, yes, they differ in functional group. For example, this is dimethyl ether and this is ethyl alcohol. Both have the same molecular formula, both contains 2 carbon and 6 hydrogen and 1 oxygen, but one has ether as the functional group and the other has alcohol as the functional group. So both are functional isomers. Now coming to the next one, that is the 30th number question. So choose, we have to select from 1, 2 and 3 which one of them are functional isomers. So now let's see here. In the first there are 3 carbon atoms, so this will be C3, 6 hydrogen atoms, so CH6 and O. Again here there is 3 carbon atoms, so 3 and 6 hydrogen atom and 1 oxygen atom. And again here there are 3 carbons, so 3 C3, sorry, H6 and O. So all of them have the same molecular formula. Now let's see, 1 and 2 have the same molecular formula, so they are the isomers. And in 1, this is the ketone functional group. The functional group is ketone here, and here the functional group is aldehyde. So 1 and 2 will be the functional isomer. Now coming to this one, it contains 2 functional groups, that is alkene as well as alcohol. So 1 and 2 are functional isomer because they have ketone and aldehyde functional group. 1 and 3, now it has ketone and it has alkene and alcohol, so again these 2 will be functional isomer. Coming to 2 and 3, again this has aldehyde functional group and it has alcohol and alkene functional group, so again these 2 are functional isomer. So all of them are functional isomer in this case. Coming to this one, so we have to select the functional isomers here, which will be the functional isomer in this case. Now this is the first, in which there are 3 carbon, so this will be 3C3, sorry, and 3, 2, 2 and 1 C, so H8 and O. This is the molecular formula here. And again here this is C4 H10O. Now coming to this one, this is C4 H10O. So now if we see carefully, then 1 and 2 has the different molecular formula and 2 and 3 have the same molecular formula. So 2 and 3 will be the isomers and 1 is not the isomer. Okay, now among these the functional isomers are, so let's consider 2 and 3. Are they functional isomer? Here the functional group is alcohol in this case, and here the functional group is ether. So they have the same molecular formula, that is C4H10O, and they have the different functional groups, so they are the functional isomers. So in this case 2 and 3 will be the functional isomers, whereas 1 is not an isomer of 2 and 3 both, because the molecular formula is different. Coming to this 32 question number, 2 is the functional isomer of, so let's see the three structures here. In the first case, they have the same number of carbon atoms and 1 pi bonds, so the du will be same in 1 and 2, so the molecular formula of 1 and 2 will be same. Similarly, here there are 6 carbon atoms and 1 pi bonds, again the molecular formula will be same. So in fact 1, 2, 3 all are related as isomers of each other. Now we have to select which are which type of isomers are present between them. So now let's see 2, this is the 2, it has alkene and alcohol as a functional group. So if I compare it with 1, then these two are not functional isomers, because it has alkene here as well as alcohol here, so both of the functional groups are same, so they are not functional isomers. Now with 2, so 2 with 1, 2 and 1 are not functional isomers because they have the same functional group. Now coming to the second option, that is 2 and 3, they have the ketone as the functional group. This is the ketone, and here this is alcohol. So both have the same molecular formula, but they have different functional groups. So 2 is the functional isomer of 3 only. This is the correct answer. So correct option is B in this case. Now metamers. So the 33rd problems, that is the metamers develop when. So the metamers develops when the functional group is divalent. All the functional group that are divalent shows metamers, like ether, okay, ester, these are the divalent functional group. Similarly also amine, these are the divalent, thioether. This type of functional groups that are divalent in nature, that means it has two valency, it has tendency to add with two different atoms or groups, will show the metamerism. Now metamers develop when the functional group is monovalent. No, the functional group is divalent. Yes, this is the correct option. So coming to the 34th. Now the two isomers can be metamer if they have, okay, so the first condition to show metamerism is there should be divalent functional group like thioether, ether, ester, okay, acid anhydride, amine. Now they will be metamer only if this is ether and it is attached with two group R1 and R2, and again this is ether, this is R3 and R4. So if 1 and 2, these two will be metamers only if they have different alkyl groups present on the either side of the functional group. So equal distribution of alkyl group on either side of the functional group, this is incorrect. Unequal distribution of alkyl group on either side of the functional group, this is correct in this case. So R1 should not be equal to R3 and R2 should not be equal to R4, or R2 should not be equal to R3 and R1 should not be equal to R4. If they have the different alkyl groups present on either side of the functional group, then they will be the metamers. Coming to question number 35. Now in this question there are three molecules here and we have to find 2 is the metamer of. Now this is the 2. Here ether is the functional group, and one side this is the methyl, and the another side this is the isopropyl group. Now if I compare it with 1, then here again this is methyl, and here this is propyl group. So these two groups are same in this case. Now so in this case they both will be positional isomer, because it has 1 2 3 carbon, and it also has 1 2 3 carbon in their parent chain, and the methoxy, that is the substituent here, has the different position. In this case it is on first position, and in this case it is on second position. So 1 and 2 are not the metamer, 1 and 2 are the positional isomer. Now coming to the third one, this is the ether functional group, and on the both side of this ether functional group we have ethyl group. So if I compare 2 and 3, then they will be metamers, because the alkyl groups on the either side of the divalent functional group, that is ether, is different in this case. So the correct answer will be 3 only, that is the option number B. Now coming to the question number 36. Now in this case 1 is the metamer of, let's see 1. So it has methyl group on this side and propyl group on this side. Again in the previous question we have seen that these 1 and 2 are positional isomers, so they will not be the metamers because methyl group is same on both sides. But here in this case both of them have different alkyl groups present. So in this case we can see that they can be metamers of each other. So 1 and 3, so 1 is the metamer of 3 only. This is the correct answer in this case. Coming to the question number 37. Now 3 is the metamer of, this is the 3, and it has ethyl group on the both side. Now if I compare it with 1, then it has propyl group and methyl group, so the groups are different on the either side of the divalent functional group. So 1 and 3 will be the metamer, and now I am going to compare it with 2. Then again this is methyl and this is isopropyl, so again both of them are different. So 3 is the metamer of both 1 and 2. So this is the correct option in this case. Now coming to the question number 38. 1 and 2 are, now they are not metamers of course, because they have the same group on one of the sides, and previously we have seen that they are the positional isomer, because in this case this will be the parent chain, and this will be the first carbon, this will be the second, and this will be the third one, and in this case this will be the first, this will be the second, and this will be the third. So the position of the position of the substituent, that is methoxy substituent, is different in both cases. That is the first position in the first isomer, and in this case this is the second position. So we can say that these are positional isomers. They have the same parent chain, but the substituent's position is different in both cases. So they are positional isomers. Now these are the questions from the degree of unsaturations, and we know that degree of unsaturations is also called the hydrogen deficiency index or double bond equivalence. All are used for the same thing. Now degree of unsaturation is calculated by using this formula here, so you have to just remember this formula. Degree of unsaturation equal to 2n plus 2 minus h plus x minus n divided by 2. So degree of unsaturation, here N is the number of carbon atom, H is the number of hydrogen atom, X is the number of halogen atoms like fluorine, chlorine, bromine, iodine, N is the number of nitrogen atom divided by 2. Oxygen atom has nothing to do with the degree of unsaturation, so this is not coming in this particular formula. Now, degree of unsaturation gives the deficiency of 2 hydrogen with respect to the fully saturated acyclic hydrocarbon. If the degree of unsaturation is 1, then there is the deficiency of 2 hydrogen with respect to fully saturated acyclic hydrocarbon. So let's see here, this is the cyclopropane and this is the acyclic propane, and in this case the molecular formula will be C3H8 and in this case it will be C3H6. So both of them has the deficiency of 2 hydrogen atom. So the degree of unsaturation for this molecule will be 1. For the cyclopropane it will be 1 degree of unsaturation or HDI. Now coming to the question number 39. Now the problem is we have to find the degree of unsaturation for C5H12, that is the propane, that is the normal propane. So let's use the formula du equal to 2 into number of carbon atom, that is 5 plus 2, minus number of hydrogen atom, that is 12, and it has no number of no halogens and nitrogens, so rest leave it. Now divided by 2, then it will be 12 minus 12 divided by 2, so this will be the 0 in this case. So degree of unsaturation for the first case is 0. Now if we find the degree of unsaturation in the second case, that is the C6H8, then it will be number of carbon atom 2 into number of carbon atom, that is 6, plus 2 minus number of hydrogen atom, that is 8, divided by 2. Now in this case that will be 12 plus 2, that is the 14, minus 8, that is the 6, divided by 2, and in this case the degree of unsaturation will be 3. So this is the correct option in this case. Now coming to the third one. Now, the unsaturation factor for the molecular formula C4H9NBrCl. Now let's see here. This is the formula for calculation of degree of unsaturation, and in this case we have 4 number of carbon atoms, so this will be 2 into n plus 2 minus number of hydrogen atom, that is 9, plus number of halogen, that is bromine and chlorine, so this is 2, minus number of nitrogen, that is 1, divided by 2. If we will solve it, then this will be 4 into 2 plus 2, that is 10, minus 9 plus 2, 11 minus 1, 10. So 10 minus 10 by 2, that will be equal to 0. So in this case the degree of unsaturation is 0. Now coming to the question number 42. Unsaturation factor of the molecular formula C5H8O. Now again we use the same basic formula here, that is the 2n plus 2. So carbon atom is 5 into 2 plus 2 minus number of hydrogen atom, that is 8, divided by 2. So remember, oxygen atom has nothing to do with du, so because there is no any oxygen atom term in the formula. Now if you find the value here, then it will be 12 minus 8, that is 4, divided by 2, that will be equal to 2. So in question number 42 the answer will be 2. That is the B option is the correct. Now coming to the next one. The unsaturation factor of the molecular formula C4H7Br. Now, if you use again the same formula, then this will be 2 into number of carbon atom, that is 4, plus 2 minus number of hydrogen atom, that is 7, plus number of halogen atom, that is bromine here, that is 1, divided by 2. So this will be equal to 4 into 2, 8, plus 2, 10, minus 8 divided by 2. So this will be equal to 1. Now the correct answer is option A. Now coming to the next problem. The unsaturation factor for this molecule formula C6H5NOBrClH. Now for the calculation of du, we need the number of carbon atom, that is 6, so 2 into 6 plus 2 minus number of hydrogen atom, that is 5, plus number of halogen atom, that is Br and Cl here, so 2, minus number of nitrogen atom, that is 1 here, and divided by 2. Now if you find the value of this, then it will be 12 plus 2, that is 14, minus that will be 6, that is 8 divided by 2, that will be equal to 4, and the correct answer in this case is 4. Now coming to the 45th, that is the unsaturation factor for the molecular formula C2H5 plus, that is CS3 CH2 plus. This is the carbocation, and we have to find the degree of unsaturation for this carbocation. Now let's see. You can also simply find it without using the formula, because here we can say that this is the fully saturated form, a cyclic saturated form, in which the carbon is 2 and hydrogen is 6, and here the carbon is 2 and hydrogen is 5. So there is the deficiency of 1 hydrogen, and we know that 2 hydrogen deficiency means 1 du, so 1 hydrogen deficiency means 0.5 du. So the correct answer will be this one. And if you want to find this with the help of this formula, then you can also find it, because this formula says the number of carbon atom, that is 2 into 2 plus 2 minus number of hydrogen atom, that is 5 divided by 2, then it will be equal to 6 minus 5 by 2, and the correct answer will be 0.5. So in the both case we find the same value, that is the 0.5. Now this is the 46th problem. In a compound, if degree of unsaturation, if the unsaturation factor is 1, then it means that a structure should have. So let's remember here, if there is one pi bond, then it means degree of unsaturation will be 1. If one ring, then the degree of unsaturation will be 1 du. If there is CC double bond, so it has one pi bond, so here du will be 1. If there will be CC triple bond, so again there are 2 pi bonds, so here du will be 2. If one ring, then du will be 1, and if it has 2 rings, so there are 2 rings, so du will be equal to 2. So one ring contribute to 1 du, and one pi bond also contribute to 1 du. You have to remember this now, and it can also be seen by using this also. This is one ring, and if we write the fully saturated form of this, then there will be one deficiency of hydrogen. This will be C3H8 and this will be C3H6. This is the molecular formula of this cyclopropane, and this is the molecular formula of propane. And now if you see carefully here, there is the deficiency of 2 hydrogen in these 2 molecules, so this will be 1 du. So if there will be one ring, then 1 du, and if there will be one pi bond, then it will also contribute to 1 du. And since in CC triple bond there are 2 pi bonds, so the du will be 2. Now So if unsaturation factor is 1, then it means that a structure should have so either a pi bond or a ring. This is absolutely correct. Only a pi bond? No. Only a pi bond is not the correct. The molecules should have a ring also, may have a ring also, because this it has also one du. So du equal to 1 does not mean that it has only a pi bond. Now only a ring, this is also not correct. Both a ring and a pi bond, so this will be incorrect, because in this case one du will be for this and one du will be for this, and the du will be 2 in that case. So the correct answer is A. Coming to the question number 47. If the unsaturation factor is 2, then it means that, okay, either 2 pi bonds or 2 rings. Yes, correct. 2 pi bonds will contribute to 2 du. 2 rings also contribute to 2 du, 1 du for each ring. One ring with 1 pi bond. So 1 du will be here and 1 will be here. So again there will be 2 du. So this is absolutely correct. Only 2 pi bonds? No. Only 2 rings? No. Because it has also a du of 2. Sorry, a du of 2. It has also a du of 2, but there is no any pi bond. So the du equal to 2 does not mean that it has only 2 rings. It may have 2 pi bonds also and 1 pi bond and 1 ring also. So the option A is the correct in this case. Now coming to the question number 48. In this problem we had to find the degree of unsaturation, that is the unsaturation factor for this molecule. So this is the benzene ring, so let's draw the structure here. There will be 3 pi bonds in this ring, and this is the aldehyde. So basically this is benzaldehyde, and this is the structure. Now let's find the number of pi bond. So there is 1 pi bond and there are 3 pi bonds in the ring, so all will give up to 4. So there are 4 pi bonds in this particular molecule. Now number of ring, and this is only, there is only 1 ring, so this is 1. So total will be 5 and the du will be 5 in this case. So all the pi bonds will contribute 1, so there are 4 pi bonds, so it will contribute to 4, and 1 ring, so it means 1 du, and now total is 5. So the du of this molecule will be 5. Now this is the acid anhydride of benzene 1,2-dicarboxylic acid, and we have to find the degree of unsaturation or unsaturation factor for this molecule. Now let's draw the molecule. This is the benzene ring, and there are 2 rings also. So first number of ring is 2 here. This is the first ring and this is the second ring. Now coming to the pi bond, this is the 1 pi bond, second pi bond, third, fourth, fifth, and there are 5 pi bond. Sorry. Now the total is 7. So the du for this molecule will be 7. So that's the end of this lecture. Kindly subscribe this channel and also share it. Thank you very much.